Hi, this is Mrs. Rodolfi, and I'm going to go through the Unit 1 study guide. Directions: show all work or explain your reasoning. Use desmos.com/calculator to check your answers when applicable. Now, I know we haven't done a lot of Desmos in class. We've done a little bit, but remember, you always have access to the online calculator during tests. So I would suggest using it as you're working through these problems just to see what it looks like on there and how it can help you. But I'll definitely be showing you a lot more with those in future units. All right, let's cube. Use the cubes marking and annotation method to mark the text. So the Tyler Zoo must have 92 bamboo trees planted. So remember, we circle key numbers and units in the koala enclosure when one koala is present. For each additional koala, the number of trees must increase by 23. The zookeeper started the table to show the number of trees present based on the number of koalas. The Cincinnati Zoo must also have a certain number of trees planted based on how many koalas live in the enclosure. For each koala, the number of trees must increase by 35. The zookeeper started a table to show the number of trees present based on the number of koalas. All right, so we circled the key numbers and units. U is underline the question or what's being asked, which those are not in this first paragraph. The questions are below. All right, then B is for box math action words. So things that help us to fill in this table right now. So we know that for the Tyler, so I'm going to put a box Tyler Zoo, for each additional koala, the number of trees must increase by 23. And then for the Cincinnati Zoo, they also must increase by 35. All right, so the Tyler Zoo, we know it's increasing by 23. And then the Cincinnati Zoo, we know it's increasing by 35. All right, so let's fill in the table. So you always have access to your calculator on assessments. So I would always type in, so it starts at 92. So if there's one koala, they start with 92 trees. Then we're adding 23 trees each time. 115, 138, and 161. So each time we're adding 23 trees per koala. All right, so we completed the table for the Tyler Zoo. Then identify the common difference. So remember, these are important words that you want to make sure you are familiar with. So a reminder, you can use a 3x5 note card on the test, and that's all you can use, no other notes. So I would start adding definitions and things and examples from this study guide to your note card. Write small, you can write front and back, but you can only have one note card. So I would add things, so if like common difference is something that you struggle to remember that definition, go ahead and look back in your notes and write it on the note card as you're working through this. All right, so common difference is how much is it increasing by? So it's increasing by 23, so that would be our common difference. Right, a sequence, that's another vocabulary term you need to know. So remember, the sequence is just the y values listed in order. So the first number in the sequence is 92, 115, and 138, 161. 4, let n equal the number of koalas in the enclosure at the Tyler Zoo. Use the variable n to write an expression for the total number of trees present. So if we know that it is starting with 92, so remember there's a couple of different ways to do this. We can start with 92, and the common difference is 23. So remember, 92 is when x equals 1, if we're using this format. So when there was one koala, there's 92 trees. Then we're adding 23 trees each time. Then we would do n minus 1 because we included that first koala. Then we would distribute, if we want to convert it to slope-intercept form. So then we would get 92 plus 23n minus 23. Then we can combine like terms, 92 minus 23, and that's going to give us 69. So 69 plus 23n. All right, and then if you get confused by this format, to find this, remember, this is when x equals 0. So if we have, with one koala, 92 trees, if it's adding 23 each time, we would work backwards and see how we already did it. 92 minus 23 is 69. And then remember, it doesn't matter the order. You could also put 23 in plus 69. So just be familiar that if you use this format, once you distribute, combine like terms, then it gives you the slope-intercept form. And then 5, use your expression for the Tyler koala enclosure to find the total number of trees that must be present if the Tyler Zoo had 15 koalas in their enclosure. So remember, n represents the number of koalas, which is 15, so we're going to substitute it into our expression, 23 times 15 plus 69. Remember to always put it in parentheses, and then 23. Now you can just do times on your calculator, or you do, oops, I accidentally did 25. 23 times 15 plus 69, and that's 414. 414 trees, because it's saying find the total number of trees. 6, let n equal the number of koalas in the enclosure. Use the variable n to write an expression for the total trees present in the enclosure at the Cincinnati Zoo. So now we need to use the variable n to write an expression for the total trees at the Cincinnati Zoo. So that's the other column up here, Cincinnati. So we know it's adding 35 each time, and it starts at 0. So if it's the starting point, remember that's our b value, b equals 0, and then it's adding 35, that's our common difference, which is also the same as our slope. So if we use slope-intercept form, 35n for number of koalas plus 0, which remember that's the same as just 35n. If our y-intercept is at 0, 0, if it's proportional, then we can just put 35n. If you're using the other format, for one koala, there's 35 trees, and then we're adding 35 trees each time, times n minus 1. Again, if you distribute, that gives you 35 plus 35n minus 35. 35 minus 35 gives you 0, which also simplifies to 35n, which is the same as this one. So just remember, once you distribute, combine like terms, that is the same expression. All right, number 7. Create an expression that represents the sequence, write in where in is the position of the term in the sequence. All right, so sometimes it helps to create a table. You might want to start at 0 if you like slope-intercept form. So here, we don't need a ton of rows. All right, so this, if you're given a sequence, this is when x equals 1. So the first term is 6. The second term is 11, so 2, 11. The third term is 16. All right, then let's figure out what is it adding or subtracting by each time. To find the common difference, you can subtract backwards. 11 minus 6. And that's 5. And then let's check to make sure we get the same. 16 minus 11, that's also 5. So it's adding 5 each time. So we could work backwards to find when x equals 0. So 6 minus 5 would be 1. So our b value would equal 1. And then our slope is our common difference, which is 5, adding 5 each time. So if we use those and we use n is the position of the term, our slope is 5 times n plus 1. So this could be an expression to use. If you like using the other method, we would start with the first term, which is 6. We're adding 5 each time, times n minus 1 because we already included the first term. Then we would distribute 6 plus 5n minus 5. Then combine your like terms. 6 minus 5 is 1. 1 plus 5n, or 5n plus 1. Remember, the order doesn't matter. So those both are equivalent expressions. Number 8, Jamie starts a comic book collection with 6 comic books. Every month, she adds 4 comic books to her collection. Write an expression to represent the number of comic books in Jamie's collection. If M represents the number of months that have passed, use your expression to calculate how many comic books she has after 2 years. So this is a 2-part question. So make sure you're always answering. So I'm going to put, this is first thing we have to do, this is the second thing. So let's do number 1, says write an expression to represent the number of comic books, using M for the number of months. So if she's starting with 6 comic books, that is our initial value, which is our y-intercept. And then she's adding 4 comic books each month, so that's our slope. So 4m plus 6 would be our expression. Or 6 plus 4m. All right, then we have to use the expression to calculate how many comic books she has after 2 years. Now, be mindful, M stands for months, and it's asking us 2 years, so we have to convert 2 years to months. There's 12 months in a year, so 2 times 12 is 24 months. All right, so we want to substitute M equals 24. So 4 parentheses 24, 4 times 24 plus 6. All right, then solve it. 4 times 24 is 96, plus 6 is 102. So she will have 102 comic books after 2 years. All right, the formula for velocity is velocity equals initial velocity plus acceleration time. To represent this formula, we use the literal equation v equals v sub 0 plus a times t. In the given literal equation, solve for t. All right, so first we want to undo addition or subtraction. So look at where the variable, right now it's a times t, and then it's adding v sub 0. So if it's adding v sub 0, we want to do the inverse and do minus v sub 0. Remember, these are not like terms, they're not the exact same. One's just v and one's v sub 0, so we have to just rewrite it. V minus v sub 0 equals a times t. All right, we're solving for t. So we want to keep t there. Right now it's a times t, so we're going to divide it both sides by a. Remember, divide everything. That cancels out. So again, these are not like terms, so we would just rewrite v minus v sub 0 over a equals t. Or you could change the order, t equals v minus v sub 0 over a. Number 10, the expression 12x plus 16 represents the total cost of a bicycle rental. When Danny rents a bike for 10 hours, the total cost of his rental is $136. What does the variable x represent? All right, so I would like plug numbers in and just test it out. So we know the total cost is $136. So we know that it's going to equal $136. So if it's 10 hours, that's probably what we're going to substitute for x, and let's just test it out. 12 times 10 plus 16, and let's see if it's 136. 12 times 10 is 120, plus 16 is 136. So that tells us that x represents the number of hours it's rented. And then just to break down what each number means, well, if x is number of hours, 12, if it's 12 times x, 12 is how much it costs per hour, and then 16 would be the initial value. So in this case, they're charging probably an initial fee of $16 just to rent the bike, plus $12 per hour. Number 11, solve the equation 2x plus 6 equals negative 5x plus 55. Show that you also checked. So we're first solving, and then we're also having to show that we checked. So this is a two-part one. So let's start with part one. So let's solve it. 2x plus 6 equals negative 5x plus 55. So this, if solving equations is something you're struggling with, I would write this example or find another example to put on your note card. And remember, write down the steps next to it, like label what are the constants. So just to do some color coding here. So for the constants, remember those are the numbers by itself. So those would be plus 6 and plus 55. So I'm going to write off to the side. Okay, I'll put it down here. Constants, and highlight that so we know what color it is. And then the coefficients, let's highlight in yellow. The coefficients are what we're multiplying by the variable or dividing by the variable by. So they're the one that's going to be like right next to or under the variable. So that would be the 2 and the negative 5. All right, so when you have a variable term on both sides, start with the smaller variable. Negative 5 is the smaller coefficient. Now, we want to move the entire variable term to the other side. So we're going to add 5x because that's the inverse of negative 5x. 2x plus 5x is 7x. All right, then go to the constant next to the variable. That's the plus 6. Now we want to move that by doing the inverse minus 6. 55 minus 6 equals 49. Then you look at the coefficient next to x. Right now it's 7 times x, so we want to do the inverse and divide by 7. X equals 7, because 49 divided by 7 is 7. All right, now step 2, we want to check our solution. So we're going to substitute 7 into the original equation and put it in parentheses. So anywhere I see x, I'm putting 7 in parentheses. Now just solve normally. No inverse operation. So first is multiplication. 2 times 7 is 14 plus 6. Negative 5 times 7 is negative 35 plus 55. 14 plus 6 is 20. And then be careful with these negatives. Always use your calculator. Remember, negative is down here, this little negative in parentheses. Negative 35 plus 55 is 20. They equal the same thing. It's a true statement. Our answer is correct. All right, number 12. Same thing. 1, solve the equation. 2, show that you checked your answer. So 3 plus 5n equals 5 times n plus 2 minus 7. So just to review, the coefficients are the numbers by themselves. So let's actually first distribute and then let's label those because that'll help us see them more easily. All right, so 3 plus 5n. All right, 5 times n is 5n. 5 times 2 is 10. All right, now let's highlight. So our coefficients are the numbers by themselves. And then those are the constants. And then the coefficients are the numbers that are being multiplied or divided by the variable. So they're right next to or under the variable. All right, so in this one, first let's combine like terms. 3 plus 5n we can't combine, but over here 10 minus 7 is 3 plus 3. All right, right away I can tell how many solutions this is, and maybe you can too if you can recognize the patterns with the coefficients and constants. But if you have to, we have a variable on both sides, so we want to get rid of the smaller one. Well, they're both the same, so we're going to do minus 5n. They both cancel out. We have 3 equals 3. So when you get the exact same thing on both sides, that's infinitely many solutions. Now, in order to check, you can check any number, and no matter what number you choose, it's going to work. So here, I will start with one over here. So like any number. So like let's say 5. We can do 3 plus 5 times 5 equals 5 parentheses 5 plus 2 minus 7. I'm running out of space here. All right, so then PEMDAS 3 plus 5 times 5. So first multiply 3 plus 25. And then over here, inside parentheses first. So this is 5 plus 2, which is 7. And I'm writing that wrong. So 5 times 7 minus 7. Okay, 3 plus 25, 28. 5 times 7 is 35 minus 7. 35 minus 7 is 28. All right, then you can pick any other number. So let's say I picked 2. 3 plus 5 times 2 equals 5 times 2 plus 2 minus 7. 5 times 2 is 10. 3 plus 10. 2 plus 2 is 4. All right, then add these. 3 plus 10 is 13. 5 times 4 is 20. 20 minus 7 is 13. 13 does it. So if it's infinitely many solutions, no matter what number you choose, any and all numbers will make a true statement when you substitute them back into the original equation. All right, I'm going to stop there for this video. So this will be part 1, and then to get the rest, go ahead and watch part 2. See you next time. Bye.